Pythagorean identities. Let's go get after it. That'll actually be the second thing we do. We're going to actually talk a little bit about quotient identities. Yeah, let's go look at some right triangles. This stuff ain't so bad. Don't stress. This stuff's mellow. All right, we got a right triangle. We got an angle theta that's hanging out down there in the bottom left corner. And I've labeled the triangle. A, that'll be the adjacent side. B, happens to be the opposite side. And C, well, that's the hypotenuse. So I want to just play a couple games real quick. Let's find sine, cosine, and tangent of theta. So we write sine, and then we write the angle inside is equal to, and now we write the ratio. So the ratio is B over C, the opposite over the hypotenuse. Next, let's do cosine of that angle theta. So you write your angles inside the word, right? Cosine of, there's like a parenthesis that's around that thing saying it's like we're taking this angle and it goes into cosine and it spits out some sort of a ratio. And we can say that this is equal to, and that's going to be our A over C. All right, the adjacent over the hypotenuse, we're just going right back through it. We should be comfortable with this. And then tangent of theta is just going to be equal to, that's the opposite over the adjacent. So that's B over A. That's B over A. Okay. All right. Now let's look at the numerators of sine and cosine. B, A. B over A, right? The sines comes first, then cosine. So you B over A, then look at tangent. B over A. Because the numerators represent, well, for sine, the numerator represents the opposite. Cosine, the numerator represents the adjacent. You know, the top, the numerator. And tangent's the opposite over the adjacent. So it's just the numerators of sine and cosine create tangent. So there's actually no such thing as tangent. There's only sine and cosine. I'll say that a lot. There's the tangent. You got to know it and all this shit. But look, sine divided by cosine is equal to tangent of that angle. All right, let me prove it to you. So instead, we know that tangent is equal to B over A, right? I'm just going to write this over here. We found that. It's right there. Opposite over adjacent. Now I'm just going to write into sine over cosine, and I'm going to reduce it down. You're like, oh shit, that's a big old complex fraction right there, huh? But don't worry, whenever you get stressed like this, that big line, that black line, that means division. So we'll go old school. Just be like B over C divided by A over C. Dude, you can do it now. Remember? You take the one with the divisor, or the second one, and you flip it over and you multiply. Come on, bro. You got this. So B over C times C over A. Look at that. Whack, whack. The C's go away, and then you end up with B over A. Hey, that's the same shit as what's going on over there. So you want to get this one down. This isn't to hurt you. This is to hook you up. This makes you faster. You want to know this. You want to know the numerators of sine and cosine represent what tangent's going to be. That makes shit quick. Do you really want to be doing this complex fraction bullshit and having to reduce it down every time? Heck no. Learn the trick. I mean, this seems like it's worth it. You should be lazy like me. That's what mathematicians do. We find shortcuts through shit, so we don't have to do it all the time. So what we find out is we have this identity. Get it in. Get it locked in. Tangent is just sine over cosine. And then cotangent, man, that's that reciprocal thing, which means just whatever your ratio is, you just flip that thing over. Look, just take sine and cosine and flip it over, and then you get cosine over sine. They're reciprocal functions. So get that one down. You don't have to know the tangent sine over cosine, but gosh dang, does it make life easy. We're going to learn a ton about sines, cosines, tangents, cosecants, secants, and cotangents. I beg you to just learn sines and cosines and a couple little tricks. I don't keep everything memorized. I just learn sine and cosine and how it's tied together with everything else. You know what I mean? I mean, just look at cosecant. That's 1 over sine. secant. That's 1 over cosine. Know what I mean? They all have sines and cosines in them. Tangent, cotangent, cosecant, secant, they're all made up of sines and cosines. So let's get our sines and cosines down a pat. Like those ratios from common angles. Yeah. Yeah, dude. So there it is, tangent sine over cosine. Let's go mess with our Pythagorean identity. Let's go get this. Again, we got the same sort of triangle. And we found from before that, well, actually, I'm going to go a different way. I'm going to do a different proof. Let's do this. Isn't a squared plus b squared equal to c squared? That's true, yeah. That's the Pythagorean identity. Oh, yeah. Pythagorean theorem. There it is. Well, let's play a game with it. And do you mind? Let's divide by c squared. On all, that's how we divide. We're just going to divide by this thing. So you get, what's this? A squared over c squared plus b squared over c squared is equal to same thingies over same thingy. That's just 1. And then I got to let you know, it's kind of embarrassing. But when I was a student, I was in calculus and I didn't know this was true. I remember getting stuck on a problem. If they're both squared, you could just bring the square to the outside. Eesh, embarrassing. Why did I do this? Does anybody's spider senses tingling right now? I'm like, wait a second. Didn't we just talk about A over C and B over C? Wait a second. Sine of theta is B over C and cosine of theta is A over C. Huh. Didn't that check out? Let's look. Sine of theta, that's the b over the c. And then cosine of theta, that's the adjacent over that. So that's the a over c. So, oh my gosh. I think we can replace this and get our first little ditty here. So instead of a over c, we're going to write in cosine. Instead of b over c, we're going to write in sine. And they're both squared. So we typically write it, we'd like to write it in as such. Well, not quite yet, but usually we say sine before cosine. But addition is commutative, which means you can turn that shit around. It's the same thing. The line up here is the same as the line down here. But here's how we write it. It gets written weird. Strangely, we don't typically write it with the parentheses like this. This is our shorthand for it. We say, it's like the word sin, and we square that. And then we write the angle. This is a big one. This is how we read. This is how we actually get used to reading it, because it's going to be written in this form. And this is what it actually means, is we have sine of an angle inside. This is our Pythagorean identity. Sine squared plus cosine squared equals 1 is just like, what do I compare it to in algebra? It's just like the most fundamental thing. It's like it's your hookup, it's your get out of jail free. It makes things simple. It cleans shit up. It's the crux to everything we do. Oh my gosh, is it so friggin' important. So this is what we call our Pythagorean identity. We actually have 3 of them. Now at first, I'm not going to mess around too much with you with all of these. I mean, a little bit, you're going to have to refer back to them. But there's 3 of them, and they all come out from algebra. I know this isn't a fun, exciting one. I'm just doing a bunch of proofs for you and showing you your different formulas. But the Pythagorean identities tell us sine squared plus cosine squared is equal to 1. It also tells us 1 plus tangent squared of theta is equal to secant squared of theta. And 1 plus cotangent of theta squared is equal to cosecant of theta squared. Eventually, you're going to have to know all of these. Once we start doing what's called identities, it gets rough. We got to be able to play around with these. We got to know what they mean and know how to get out of jail free with them. Because they will be the hookup when you're screwed if we actually know them. So I just did the proof. This is kind of the proof of sine squared plus cosine squared equals 1. And I'm going to show you this now, and we'll return to it later. I'll show you this piece again. So if you're done listening and you're like, this is all I can take, just tune out. You're good. I'm just going to go a step further. And I will repeat this later in other lectures. But since there are 3, really, this is how you get out of it. You're like, I don't remember my other identities. There's two other ones, and they're all actually just the same thing, just kind of with things moved around. So if in class I would point to somebody and I would ask them, sine or cosine, you choose. And whatever you'd say, let's say someone said cosine. So I'd be like, all right, I'm going to go to all of these, all three of these things. I'm just going to divide by cosine squared. Just going to divide by cosine squared. And this is too much too soon. So if you're not following, don't worry, don't trip. So sine squared over cosine squared. Sine over cosine is tangent, but they're both squared, so we write squared. Cosine squared over cosine squared. Well, that's the same freaking picture, so it has to be 1. And then have you learned what cosine 1 over cosine is? Have you got that one down yet? Because I know we just started learning it. That's secant of theta. But the cosine, we actually have a squared. And did you know that 1 is always squared? So if they're both squared, we could say it's actually just 1 over cosine all squared. And there we have, well, I wrote it as tangent squared plus 1. They have it as 1 plus tangent squared. It's the same dang thing. It's right down here. That's the same thing addition's commutative. Tangent squared plus 1 is the same as 1 plus tangent squared. And then you can play the same trick. You can play the same game with just taking your Pythagorean identity, the one that we have down, the sine squared plus cosine squared equals 1. Please learn this one. This one never goes away. I don't care which direction you go. If you ever use trig, this is just, you need it. It's like SOHCAHTOA. So instead of dividing everything by cosine squared, this time I'll divide it by sine squared. All right. So same picture over same picture. That's got to equal 1, right? Sine squared over sine squared. Now, do we know what cosine over sine is yet? If sine over cosine is tangent, cosine over sine, that's cosine over sine. Oh, that's cotangent. Okay, good. So, but since they're both squared, we'll write in cotangent squared. And 1 over sine, that's actually cosecant. And but since both of them are squared, one's always squared or cubed or whatever you want it to be. It's nice that way. We get 1 plus cotangent squared of theta is equal to cosecant squared. And that's the final one that's down here. So, whew, there's the proof. There's what's happening. These identities will come back and we'll actually use them next time. And I might actually advise you not to use them quite yet. Maybe just work on getting them dialed in and memorized. But you'll see in the next one where I'll show you some options for solving triangles that might be a little quicker than what the book or what your homework will ask you to do. So we all like to shortcut shit. So I'll see you in the next one.